All right, so we're going to start first off with cases and variables.
Not a joke.
All right, so a case is an experimental unit from which data are collected, and a variable is a characteristic that is measured and can take on different values. So they're really just things that can vary. That's what it comes down to. You guys are probably familiar with those by now. But an example just to go over these is that a third grade teacher wants to know if students who spend more time studying at home get higher homework and exam grades. So in this example, the third grade students are the cases because they are the subjects, and the variables are the homework and exam grades. So next are categorical and quantitative variables. So variables can be classified as either categorical or quantitative. So categorical variables are names or labels, or categories, if you will, that either have a logical or no logical order. And they are qualitative. So on the other hand, quantitative variables are numeric variables with magnitudes that can be placed in a meaningful order with consistent intervals. So these are numerical. So you can split quantitative variables into either discrete or continuous variables. So a discrete quantitative variable has a set value, and a continuous quantitative variable has a value between values. So an example I like to use for discrete quantitative variables are number of children per household, because that is a set number that doesn't have any decimals or fractions in it. And then a continuous variable like weight or height, 65.2 inches or 115.3 pounds, things like that for continuous. So then we can go into explanatory and response variables. You're probably familiar with independent and dependent variables. These are very similar. So an explanatory variable is known as the independent variable, and it explains variations in the response variable in experimental study. So these are what are being manipulated here. And then the response variable is what is measured. So it is the outcome that is measured following manipulations of the explanatory variable. So an example I like to use for explanatory and response is, how does the hours spent studying affect your exam grade? So here the hours spent studying would be your explanatory variable because you can manipulate it. And then your exam grade would be your response variable because you're measuring it based on the manipulation of the hours spent studying. So samples and populations. So you want to gather information from the population to make inferences. So in order to make those inferences, you gather information from a smaller subset of the population, since it's unrealistic to gather information from an entire population of people. So you gather information from a smaller subset, which we call samples. So a statistic would be a measure concerning a sample, and then a parameter is a measure concerning a population. So you just make sure you want to know the difference between a statistic and a parameter, because it becomes really important later on in the course when you're defining certain things. And then inferential statistics is when data from a sample is used to make an inference about the population. So sampling bias. So a representative sample is what we want. So it is a subset of the population from which data are collected that accurately reflects the population. So you know that this is representative of the population that you're trying to make a conclusion about. And then you probably heard of bias, which is the systematic favoring of certain outcomes. And then when you go into statistics, we have things called sampling bias, which is systematic favoring of certain outcomes due to the methods employed to obtain the samples. So what you go through to get the samples has an effect on the data. So here's an example for you. So a medical research center is testing a new weight loss treatment. They advertise on a social media site that they are looking for volunteers to participate. So is there a sampling bias present, and is there a representative sample? So here, there is a sampling bias present since they advertise on a social media site, and advertising through a social media site is not a good way to reach the entire population since not everybody has social media. And therefore, if there's sampling bias, then this wouldn't be a representative sample because it does not accurately reflect the population as a whole. Okay, so we just talked about sampling bias. Now we're going to go through some sampling methods. So simple random sampling is a method of obtaining a sample from a population in which every member of the population has an equal chance of being selected. So this is selected without replacement as well. And then the opposite of that is convenience sampling, which is a method of obtaining a sample from a population by ease of accessibility. So it's much more convenient for the researcher to get their data instead of going out to get data that is accurate, and that makes that's just better data instead of kind of just being lazy to go out and get data that's easy to reach. So convenience sampling data is not random and is mostly not representative of the intended population. So some sampling methods here, a lot of students get confused by non-response bias and response bias. Response bias is a little easier to understand. It's favoring certain outcomes that occur when participants do not respond truthfully. So it's really just about telling the truth or not. So whether it aligns with social norms or trying to please the researcher. So an example I like to use for response bias is if a teacher surveyed her students whether or not they cheated this semester on a test. So most students would say that they did not cheat on a test, even if they did, because they would want to please their teacher. And then going back up to non-response bias, which I skipped earlier, it's favoring certain outcomes that occur when the individuals who choose to participate differ from the individuals who choose not to participate. So this can be a little confusing, so I'll try to put it in context for you. So a restaurant invited their recent customers to complete an online survey. Customers who had really strong feelings about their experience, either positive or negative, were likely to complete the survey, while customers who had a neutral experience were much less likely to complete the survey. So here it's just really about who's participating in the study, while response bias is the results of those who do participate in the study. So experimental and observational studies will come up a lot this semester. So an experimental study is a study in which the researcher manipulates the treatments received by the subjects. So this is also known as a scientific study. And then an observational study, also known as a non-experimental study, is when the researcher collects data without any manipulations. So they leave it just up to nature. So a problem with observational studies is that they do not take confounding variables into account. So confounding variables, also known as third or lurking variables, they vary between cases and they're related to both explanatory and response variables. So sometimes researchers don't take them into account in observational studies when thinking about age of participants or certain factors such as weight, height, some other things that can get in the way of the results that may skew them that actually don't have an effect from any of the variables that they didn't even think about. So just be on the lookout for those and understand that observational studies don't take them into account. So independent and paired samples can sometimes trip students up, but independent groups are cases in each group that are unrelated to one another. And then you have paired data, which is related to one another. So the difference between the two here is that paired is the samples are dependent on one another, and the independent groups are independent of one another. Um, it sounds too simple, but that's just how it is. So a t-shirt company is studying how many t-shirts American men and women own. In one research study, they take a random sample of 1,000 American adults and ask each individual if they identify as a man or woman and how many t-shirts they own. So this is an example of an independent groups study, and it just, one thing to just take away here is that the number of t-shirts that men own does not depend on the number of t-shirts women own. So if women own more t-shirts, that doesn't mean that men will own less t-shirts or more t-shirts. They're independent of one another. And then paired groups they are dependent on one another. So you may have them later in the semester known as dependent samples or matched pairs, but an example here is that an instructor wants to compare student scores on a midterm and final exam. She obtains a sample of students and records each student's midterm exam score and final exam score. So this is just comparing one student's prior exam score and another student's score after. So sorry, I'm getting kind of distracted. So they compare. So the teacher here is comparing the students' scores for the midterm and the final. So they are paired in this case because it's comparing data before and after something happens. So each student, usually with paired, you'll either see a relationship between two subjects, so such as like twins or mother and daughter or sister and brother, something like that. Or you'll see something like this, which is comparing scores before and after an exam, for example. Okay, so control groups, placebos, and blinding. So a control group is an experimental condition that does not receive the actual treatment. So they may receive a placebo or they may receive nothing at all. A placebo is something that appears to the participants to be an active treatment but does not actually contain the active treatment. So, for example, if each group was given a type of pill, one group could be given a pill with the active treatment in it, and the other group could be given just a sugar pill that didn't have anything in it, but that would be the placebo. And then blinding is used a lot to avoid bias. You may see this on like medical TV shows or something like that. I definitely have seen it a lot. And there's single blind study and double blind study that we'll go over. So a single blind study is when a research study that only the participants do not know the treatment they've been assigned to, but the researchers do. And then a double-blind study is when neither the participants nor the researchers know which case is assigned to each treatment. So it's really just about who knows which case is assigned to each treatment. And in a single-blind study, only the participants don't know. And in a double-blind study, neither the participants nor the researchers know. Okay, so I have a couple review questions here for you guys. So you can read through each of them, and then once you get your answer, you can just put it in the chat box that you guys have been talking in, and we'll go over it just to see how you guys are grasping this information. So, which of the following statements is true about this study? I'm gonna mute myself for a little bit, and then you guys can go over this. Alright, so we have a bunch of answers here, but the answer is B. So we're going to go through each answer one by one. So A, so it's looking for the statement that is true about the study. So the double negatives kind of get confusing. Um, so the study lacks randomization. So you want to make sure that you're aware that this is an observational study, since it's it just states that it's collecting data concerning the 10,000 6-month-old babies, whether or not the baby was being breastfed was recorded. So there's no manipulation of there's no manipulation of the data here, but so in this so there's no randomization. Um, C, the group that is breastfed is the placebo group. So since there's no blinding, there's no placebo. Um, yeah, it's just an observational study. And then D, since it's an observational study, there it cannot be an experimental. Um, you won't see a question like this normally because we don't go over replication anymore in this class. So the reason I kept it on this particular slide is because you still could get the answer, since the other three answers we have gone over, and you should know that those three weren't true. So the answer should be B. But you won't see a question like this on one of your exams or homeworks because you don't go over replication in the class. Okay, so for your second review question, it's just looking for the response variable in this certain study. Okay, so it looks like most people have their answers in. So the answer here is C, reading comprehension scores. So the sentence you want to focus on in this paragraph is the first one. So they want to use students' intelligence test scores to predict the reading comprehension scores. So it's predict is really the key word you want to look for here. So they're looking to measure the reading comprehension scores. So we're basically just looking for the variable we want to measure in the end, and that is our response variable, and we want to predict the reading comprehension scores. So that's why that is our answer. Here, intelligent test scores would be our explanatory variable. So I think we have one more, so this should be a pretty quick one. Which of the following is not a quantitative variable? All right, great. So everybody got this one. So favorite ice cream flavor is the answer. So really just going down the line of testing which variables are which. So weight, children per household, and running distance are all quantitative. And then favorite ice cream flavor is categorical. All right, so that is it. Thank you guys for being so patient.